Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. So currently we are still forming our basic knowledge of recursion, right? Now currently whatever problems I solved was somehow related to some kind of number or something. But in problem solving, you always have to deal with some data structures as well. For example, arrays. There will be a lot of case when you have to combine a recursive solution with arrays, right? And generally whenever I see that, I try to follow a set format in order to form a recursive relation. And based on this, we will solve some very basic questions, and later we'll solve some harder problems as well. So whenever I see that there are arrays and recursion that might come up together, in my recursive relation function, I keep at least two values, at least two parameters we can keep. What are the two parameters? First parameter is the array itself, and the second parameter is the IDX. And then there can be more parameters, of course, but at least these two parameters we can safely keep. Let's talk about these two parameters. Now this array parameter denotes the array in hand, and array generally is not updated, right? So most of the questions that you will see, generally what will happen is, if you have to involve arrays with recursion, the arrays won't be getting updated every now and then. You'll be getting a fixed array, and that array will keep as it is, will remain as it is till the last of the problem, right? So that is this array parameter. So this will not change. For example, if you see the Fibonacci relation, here we were taking the value of n, and in every call, every recursive call. So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video.
Value of n was changing. But in case of arrays, most of the time what will happen in two recursive call, the array parameter will not change, right? But there is a second parameter, right? This denotes the current index we are exploring in the array. This is the current index that we are actually exploring in the array. Because if you see iterative problems of arrays also, in any iterative array problem also, you have to at least read the array, right? In any iterative array problem, you somehow at least read the array, right? In any iterative problem, you have to read the array. To read the array, you apply a for loop on the array. Similar thing exists with recursion as well. If there is a problem of array that you have to solve recursively, you have to at least read the array, right? At least reading the array will be required. Now here, we are not applying any loop. We have to recursively iterate on the array, right? We have to recursively go on the array. If you have to recursively go on the array, then we need some mechanism, right? We don't have for loops. We need some mechanism. And then this variable idx is going to help us. This variable idx is going to denote the current index of the array we are exploring. And in any recursive call, we can go to idx minus 1, idx plus 1, idx minus 2, so on, wherever we want. We can actually change the value of this idx. We will keep array as it is. We'll change the value of this idx, and actually this is going to help us in order to iterate over the array recursively, or move on the array recursively, or read the array recursively. And 90 to 95% of the time in any array based question, I will be forming my recursive relation in this format. There will be some more arguments that can be there based on the question to question, but at least we need the array and the index to travel. For example, let's take a very basic question. Let's say print array recursively, right? You already know how to print an array. You can apply a for loop, but this time you have to print an array recursively. For example, the array that is given in front of you is 1, 2, 5, 8, 3, 9. Okay. Let's make it 11, 21. Okay. This is the given array. And let's say you want to print it. If you want to print this array, you have to read this whole array, right? You have to at least read this whole array. How can you read this whole array? Let's start talking about it. And we have to do it recursively. So you have to do it recursively. We have that set format, base case, recursive assumption, self work, right? Okay. So what I'll do is I'll write a function f of arr comma idx. There are no other parameters involved in the question, right? There is no k, x, whatever extra given in the question. So I feel like just these two parameters should be sufficient. And what this function will do, this function prints the array from index idx to n minus 1, right? Index idx to n minus 1. right? So this function will take the array and will take some index, and from that particular index up till the last index, this array will print everything for us. So actually, when we will call this function, we will call f of arr comma 0, because this is the expectation, right? We want to print everything from 0 to n minus 1, and this is some intermediate in between state, right? Now how can we get it? It's kind of like that same homework, or I would say attendance thing. I want to print every element from idx to n minus 1. I don't know how to print everything, right? I don't know how can I mark every student's attendance from index idx to n minus 1. So what I'll do is, hey, I don't know how to mark everyone's attendance, but I can mark my attendance, or in this case, you can print arr of idx, right? You can mark your own attendance, and then you can give the attendance sheet to the next student in line and say, hey, I have marked my attendance. Now from here, you can mark your own attendance. Who is the next student in line? idx plus 1. That's it. This is the recursive relation, right? So what we have done here is, we wanted to implement the function f of arr comma idx. And we assumed that the definition of this function will somehow print the array from index idx to n minus 1, right? So from some index idx to n minus 1, it will print. So I said that I don't know how to print all of these elements. I just know how to print the current element. So you printed the current element. And once you have printed the current element, you say that, oh, I have solved some part of the problem, right? Let's say you wanted to print 10 elements. I have at least printed one element. It's a win-win situation, right? I see this as a totally win. So now because I have done some task, I don't want to do everything. Why not delegate the task to the next person? So you'll say, I have printed myself. Why not you go and print everything from idx plus 1 to n minus 1? And that's it. And that's it. What will be the base case? What will be the base case? In the base case, we can say that if idx becomes equal to n, or anything greater than or equal to n, that means what's happening? The last student was n minus 1 whose attendance was expected to be marked, or you can say the last element which was expected to be printed was at index n minus 1. You are at index n. There is no one, right? That means the attendance is done. That means the printing is done. If the printing is done, you just return. You don't need to bang your head, right? And that's it. That's it. Now, whatever I wrote here, right? I will just implement everything as it is, and you will see things will be done. Let's make a new file. Print array. Again, I know it's not a very good practice to always write function names as f, but in recursive code, I try to keep things as clean as possible. Public static. And now we don't need to return anything. We just need to print, right? So void f. How many arguments do you have? You have an array and you have an index. So you'll pass an array and you will have an index idx, right? Here we go. And then you print the current index arr at idx, and then you make a call to f of arr comma idx plus 1. This is your self work, and this is your recursive assumption, or you can say delegation, that I have done some work. Please, rest of the people, carry on this work. And your base case, if idx becomes greater than or equal to arr dot length, that is equal to n, right? You return. everything is printed. Don't do anything now. And that's it. And that's it, right? So let's say you have an array 31, 22, 12, 4, 2, 1, 6. Okay. And let's say you call for f of arr comma 0. Why arr comma 0? Because we want to print everything from 0 to n minus 1. 0 to n minus 1. And what is the definition of this function? The definition of this function is this function prints everything from idx to n minus 1. Right, that's it. Let's try to run this code. And you can see pretty easily we are getting 31, 22, 12, 4, 2, 1, 6. And that's it, right? If you want to dry run this, let's try to do a quick dry run. I'll just directly do the debugging here. So you can see you're on line number 13. And if you see your call stack, inside your call stack, you are in your main function. So let's go inside this. Now you can see after the main function, you have made your first function call. You are on line number 5. What is the value of index? See, index is 0. So you are on the 0th index. Is 0 greater than or equal to length of the array? No. So you move to the next line. And when you move to the next line, you print ARR of 0. So you can see 31 got printed. And now what you have done your task. The 0th student of the class has marked its own attendance. And now it is going to pass the baton to the next student. So what you do, you have printed the 0th index. Now you say, hey, first index, starting from the first index, just go and print everything. And now we will go here. So you can see there was only one function call. The moment I go inside this function, you have 2 F calls, right? Again, index is 1. Is this greater than length of the array? No. You print index 1. You can see 22 got printed. And then now you will expect the next student to print everything from second index to the last index. Even the second student will say, I can just print the second element. It prints 12 and move forward. And so on. Sorry. So you can see 4 got printed. Let's quickly go till the very last. 2 got printed, 1 got printed. Now you are at the last index. Is index greater than length of the array? No. You print the last element, that is 6. And you move here. Now index is equals to 7. Is 7 equal to a length of the array? Yes, 7 is equal to the length of the array. You can see now you will return. See, nothing got printed. These 2 lines are skipped and you return. The moment you return, you can see one F call will be removed. You can see that is removed. Oh, I actually moved directly further only, right? Yeah, but I believe that much part is pretty simple. I by mistake clicked on the play button. But if you want, I can just short the array a bit and debug again. Let's go. And we are at the last element. Let's go. Now you're at the last index. See, this is done, right? And oh, it's skipping all of the previous calls. No worries, but I believe you got the concept, right? So this is the framework that I generally use in order to solve array-based problems, that at least you need to read the array. In order to read the array, this kind of an index can definitely help you. And this index, you have to just keep an eye that it doesn't go out of the array, and it is always you are keeping in between the array, and everything should be sorted then. Now, before we move forward to any question, one very basic mistake that a lot of students do in recursive problems is, let's say if there are some parameters in a recursive problem, and there is, let's say, some value idx and then some more parameters, and you make a function call. If you want to change something, you can change. And then you do idx plus 1, or let's say you do idx minus 1 or idx plus 2, something like this. But some students make a mistake and they do something like idx plus plus, or you do plus plus idx, these kind of stuff. Now, why this is considered as a bad practice in recursion, and this can lead to bugs and errors. Okay. The thing is that if you do the first one, this is definitely a disaster. It's a disaster. Why? When you do a post fix operator, what happens is if you do idx plus plus, then you pass the original value of idx in the function f. For example, if the value of idx was 0, when you do 0 plus plus, what happens is it doesn't first update it and then pass. Because it's a postfix operator, that means the original value of idx will be passed inside function f, and when this function f will be done, then you increment the value of idx to 0 to 1, right? Okay. But that's a problem, right? From f of 0, you will make a call to 0 plus plus. That will still remain 0. Then you will make a call to 0 plus plus. That will still remain 0. And you will always and always make a call to f of 0, right? I can even show you that. For example, if you do idx plus plus here, it's a disaster. Sorry, my bad. What is this temp code? My bad. Just a second, guys. Okay, print array. And you can see it's a stack overflow. Why stack overflow? Because the call stack is now getting same function call again and again, and the memory got filled. Now, instead of this, if let's say you do plus plus idx. Now, plus plus idx is still relatively good, but it's still not the best practice. Why? If you run it, you can see you got the answer. But here, there will be still problems. Why? In any question, let's say you do some task before the recursive call, and after the recursive call also you do some task. Now, if you do plus plus idx, and inside this function you are passing idx, what will happen? This will actually update the value of this local variable idx, and the updated value will be passed inside function f. For example, if it was 0, if you do plus plus 0, you will make a call to 1. Then plus plus 1, you make a call to 2, and so on. This is good. But the thing is, when you will come back in recursion in the same function calls, here you will come back, right? When you come back, then the value of this idx variable has been updated. So until unless you want to access the updated idx value here, till that time you should not do it. If you want to get the access to updated value of idx here, then it's good. But if you want the same value of idx, that in general case we need, because this function overall is dependent on just idx. We don't want to actually update the value. So that is why when you do idx plus 1, you pass the updated value. That means if it was 0, you pass 0 plus 1. Then it was 1, then you pass 1 plus 1. But the original value of idx never changes. And same thing exists with minus 1, multiply, and so on. So always make sure you never make this mistake.